Good morning and welcome to StarWind Software's Storage Virtualization and iSCSI SAN software presentation. Today we'll be looking at how to cluster SQL Server over iSCSI and some best practices that you can use when using iSCSI to really make sure that you get the most for your money when you're developing these solutions. A little about myself real quickly. My name is Denny Cherry. I'm a senior database administrator and architect for a company called Awareness Technologies here in Southern California. I'm a Microsoft MVP as well as a Quest Software MVP, and I hold a large number of Microsoft certifications on top of that. So let's go ahead and delve into the presentation. So the first thing you're going to want to look at when you're developing an iSCSI solution is your network configuration. This is, since iSCSI is going to be running over your standard Ethernet network, this is where you're going to get a lot of bang for the buck as far as spending some time configuring and getting the right environment right from the beginning. So the first thing you're going to want to make sure you have is a gigabit network. In the home environments, you may not be seeing this as far as building a lab at home or something. Hopefully your production work environment is already gigabit or possibly even 10 gigabit. That's come out on quite a few systems now where 10 gigabit is kind of the new standard. One setting you're definitely going to want to enable is jumbo frames. What this does, it's a network configuration setting, so you have to set it on your network switch and on your server and on your storage. So what the setting does is it allows TCP/IP to put a lot more data per packet, which will greatly increase the amount of throughput you can get on your Ethernet network. Now, setting this won't increase your internet bandwidth by any means because the internet runs at a standard non-jumbo frame setting. But if you enable this within your LAN on your specific iSCSI host, you'll get a lot more throughput on those hosts. The next thing you're going to want to look at is going to be actually segmenting off pieces of your network. This will help reduce your network overhead and reduce contention on your Ethernet network. There's a couple of different ways you can do this. You can either do segmentation physically, whereas you go out and you buy additional network switches and you put your iSCSI traffic on those physical network switches so that they're totally isolated, or so that traffic is totally isolated from the rest of your Ethernet network. Or if you've got fairly decent Ethernet switches in your environment already, you can do what's called VLANing, which is where you basically carve up a single network switch so that certain ports can only talk to other ports directly. So this way you can't get any sort of crosstalk between the switches. There's no right answer when it comes to choosing which of these techniques you're going to want to use. Some implementations, VLANing is going to be your better option. Some physical network switch segmentation is going to be your better option. It all is going to depend on your environment itself. If you've got an extremely high load Ethernet network already and your backplane on your switches is already near or at capacity, then adding an iSCSI workload into that environment is probably not the best idea. And at that point, you're going to want to actually go out and buy some additional network switches and offload the iSCSI traffic onto that new network as opposed to putting it onto your existing Ethernet network. That will obviously drive up the cost of your implementation, but you'll get a much more satisfactory result at the end of the project. Now, redundant network links also very, very important. These give you a couple of things. One, they give you additional bandwidth between the host or the server and the switch, or the switch and the iSCSI target, which would be a storage array or a machine running StarWind iSCSI target. So you get the additional bandwidth of having multiple NICs, but you also get some redundancy in there as well, so that if one of those NICs fails, or if a cable gets unplugged or gets cut or something happens, then you still have access to your host or to your target through the Ethernet network. You're not just losing all your storage connectivity, which is obviously, when it comes to SQL Server, a very, very bad thing to have happen. because SQL will just shut down. Well, it won't actually shut down. It'll just simply suspect all your databases, and then you got to go recover all that and hope that the whole thing didn't blow up at just the right point where your databases are actually corrupt and suspect. So with Windows clustering, there are obviously lots of requirements that you have to deal with ahead of time. First software requirement we're going to look at here is what Windows version you're running. Windows clustering still requires a Windows Enterprise Edition or higher SKU, so it's going to be Windows Enterprise or Windows Data Center editions only. I still cannot cluster on Windows Standard. As far as the SQL versions go, you can cluster SQL on Standard Edition, as hopefully everybody knows by now, starting with SQL 2005 up through 2008, and we'll assume that's going to continue in the new 2008 R2 release that's coming out soon. If you want a 2-node cluster, Standard will work fine. If you need anything more than a 2-node cluster, then you're going to have to move up to the SQL Server Enterprise Edition. Now, if you are going to have redundant network links between your, either on your host or on your target, then you're going to need some sort of multipathing software. And this is, if you've got multiple target NICs on either side, and you're going to be have multiple paths. So basically, if anything's going to use more than one NIC, then you're going to need multipathing software everywhere. So you've got a few options here. Windows 2008 and 2008 R2 both have excellent native MPIO drivers, multipathing input-output drivers, that you can use. If you're in a Windows 2003 environment still, it's got a multipathing driver, but it's not as good as the 2008 one. If you're in a Windows 2003 environment, I would highly, highly recommend that you look at a third-party MPIO driver, and there's a few of them listed there in the slide deck. These aren't free. You do have to go out and buy these. But these are all very, very good multipathing drivers. If you're in Windows 2008, you can either use the native one, which will work just fine, or you can use one of these third-party ones. These are either-or scenarios. You don't use more than one multipathing driver, or your system's just going to get extremely confused. Just a little bit about these multipathing drivers real fast. What these do is when you have your host, which is your server, so in our case a SQL server, talking to your target or your storage array, works the same in an iSCSI target or a storage array. You create paths from the server to the storage. So for each path you have, the storage is going to present the volume on that path. So if you're presenting a single LUN or single disk to your server over two paths, for example, Windows is going to see two different drives, and you're going to have to assign two different drive letters. What the multipathing software does is it tells Windows, hey, that's the same disk on both paths, so it only needs a single drive letter, and now I can access that disk over both of those paths. So I don't have to worry about, okay, so if I lose a path, I have to change my drive letters, I got to restart my database, make sure everything comes back up. You don't have to worry about any of that. Windows or the multipathing driver or the multipathing software will take care of all that automatically for you. So the next thing you're obviously going to need is you're going to need an iSCSI target to attach to. This could either be a storage array on a SAN running an iSCSI target. The new EMCs offer that. Some of the new IBMs offer that. I believe the new HPs also offer that. Or you're going to need a software iSCSI target, which is what we're here to talk about today, which is something like StarWind's iSCSI target. You're also going to need some iSCSI software on the host. So if you're using Windows 2008 or 2008 R2, that's going to be built in natively for you to use automatically. If you're using Windows 2003, then you're going to need to go find an iSCSI host initiator that you can run on your server, or you're going to need a physical iSCSI initiator to physically plug into the device. So you're going to need to spend some time designing your network to be able to support clustering. Clustering's got some additional network requirements beyond what you normally do. Now, the stuff I'm going to be talking about here is going to be your best practices, best case scenario setups. You can do some more minimal configurations and have everything work just fine. However, this is the configuration that I recommend when I'm talking to people about clustering. So the first thing is the redundant network links. We already talked about that. So you're going to want at least one network link per network that you're talking to. So we're going to be talking to two networks, which we'll talk about in just a sec. So to make all this work in a perfect environment, you're going to want at least 4 networks, or 4 NICs, 2 per network. Now the catch here is that sometimes SQL clustering doesn't like having the multiple redundant links on the heartbeat network, but you can work past that with a little bit of monkey work. For the purposes of the demo, these are all VMs, so the redundancy is all handled at the physical side. So on the virtual machine side, I'll only be having one redundant, or one NIC per network, so I'll still have the 2 NICs to deal with. So like I said, we're going to have 2 networks. These should be on totally independent subnets. You can see here I've got the 10.0.0.0/24 subnet and the 192.168.0.0 subnet. The 10.0 subnet is our public subnet, so that's what we're going to be. That's what all our clients are going to be connecting to, and that's what the server communication is going to be using. Our heartbeat network is that 192.168 subnet. So you can see it's a /30, which means basically there's 4 IPs in that subnet. It's about as small as it can go. So the 4 IPs on that particular subnet would be .0, .1, .2, and .3, with .0 being the subnet name and .3 being the broadcast address, leaving .1 and 2 for our actual boxes. And that would be a subnet mask of 255.255.254 or 252, I believe. One of those two. So on the public side, we'll be using 10.0.0.0/24, which is your standard subnet, class C subnet, so 255 IPs to work with. So you can see on this little chart on the side here, I've got 2 hosts. That's SQL 01A and SQL 01B. Those will be the VMs that I'm going to be clustering. Those each have their own IP address on that LAN, .5 and .6. SQL 01 is going to be the name of the cluster when I actually build the cluster together. That's got to have its own IP address, .7. As I'm using Windows Server 2008, DTC gets clustered under its own name. In Windows 2003, it was quite common to put DCC under the root of the cluster, or the cluster name, which in this case would be SQL 01. Now, Windows 2008, it wants it separated, so that's going to be a separate IP address, and a separate name. So you can see there the name is SQL 01 DTC, and the IP address is 10.0.0.8. And the SQL server obviously has to have its own name and its own IP address. It should be SQL 01 V01 in this case. That's kind of the naming convention I like to use. And its IP address is going to be the .9 IP address on that subnet. So you can see only the hosts get IPs on the heartbeat network, but the servers and all the virtual worlds will be creating all get IP addresses on that public network. So the basic process we're going to go through on the VMs is fairly straightforward. First thing we're going to do is we're going to install cluster services on the hosts. That's just basically getting the hosts to have all the pieces of the OS that it needs. Next, you install MSDTC, which we will be doing as part of our install. The next thing we'll be doing is configuring our shared storage using StarWind Software's iSCSI target, since that's our iSCSI host that will be, or iSCSI target we'll be connecting to for our storage. Once that's done, we'll be clustering the MSDTC service, because that is being installed on our cluster. Once that's done, we'll install SQL Server on the first node. We'll then install SQL Server on any additional nodes. In this case, it's just a 2-node cluster. And then you can test your failover back and forth. Okay, so we're going to go ahead and get started with the demo portion of today's presentation. So the machine we're looking at right now is going to be our iSCSI target. So this is our Windows 2003 server running the StarWind iSCSI target software. So we're going to go ahead and bring up the connection manager here. We've already connected to the target, or to the target. So we're going to go ahead and add a few devices here. So we're going to be using disk bridge devices today. So this is where we're going to actually be mapping a physical hard drive on this machine to a iSCSI target, or an iSCSI host. rather. So in this case, we've got six volumes on the disk, on the server. The first one here is the C drive, so we're going to ignore that. So we're going to be adding disks 1 through 5 as target, as iSCSI disks here, or iSCSI devices rather. So we're putting them in synchronous mode or asynchronous mode, and we're going to allow multiple concurrent iSCSI connections. So that's going to allow both nodes of our cluster to connect to these devices at the exact same time. So the reason we are mounting 5 devices is we have one for our quorum, which is going to be used by Windows to actually manage the cluster itself. That's where Windows keeps some basic settings as well as some log files as to what the cluster is actually doing. We've got one for MSDTC, since that's going to be in a separate resource group, and so it's going to need its own set of settings. And then we've got 3 for the SQL Server itself. One for the data, one for the log, and one for the tempdb. So you can see we've got all 5 of our devices mounted here. So they're all being presented over the iSCSI network. Alright, so we're going to go ahead and jump over to the first node of our SQL cluster here, which is the machine that's currently up on the screen. So this is going to be a Windows 2008 Enterprise Edition server. So the first thing we're going to need to do is we're going to go ahead and open up Server Manager. You can either grab it from Administrative Tools here, or right down here, in the Quick Launch bar. So we're going to use this to go ahead and actually add in the MPIO driver. So we're going to install the native Windows MPIO driver to handle our multipathing requirements. And then we're also going to be installing the actual failover cluster functionality. So we select failover clustering and MPIO. Those are the only 2 pieces you actually need to run a cluster. Well, you don't really need the failover drive, the multipath IO driver, unless you're going to have multiple paths. And one thing to note, if you do decide to build a cluster under VMware or under Hyper-V, don't install the failover clustering before you build your machine. So don't build a template that's got failover clustering already installed, and then try to deploy that template and build a bunch of machines that you're then going to cluster. When you install this failover clustering, it installs a virtual NIC driver that's only used for clustering, and when you deploy that machine and it runs through sysprep actually doesn't change the MAC address of that NIC, and you'll actually fail the validation wizard that we're going to run through once we actually get to actually building the cluster. So if you are going to deploy machines from a template, which I've done, you'll want to make sure to not do the failover clustering ahead of time, and actually do that after you bring up the machine under its actual machine name. Alright, so if everything's gone as planned, you get to a screen that looks something like this. It may tell you need to reboot, it may not. All depends what files are open, and if you've already had the failover clustering software installed before, which I have. So now we've got our components installed. At this point you would need to go ahead and go to your second node of your cluster and go ahead and do the exact same configuration settings. So now on our first node, we're going to go ahead and go to Start and then Control Panel. So what we're going to do is we're going to go ahead and open up our iSCSI initiator and go to the Discovery tab, and that's where we're going to type in the IP address or IP addresses. In this case, we only have one of the server that's hosting our storage for us. So if you've got 4 NICs on your iSCSI target, you're going to enter all 4 of those IP addresses right here. Flip over the Targets tab, and you'll see all the storage that we've been assigned from the iSCSI host. So we'll go ahead and click on Log On, and go ahead and connect all these storage devices real quickly. And you see we're enabling automatic restore, which means that it's going to find the storage when the computer reboots. If you don't do that, nothing's going to work real well. And we're enabling multipathing, so that if we decide to set up a second NIC on our iSCSI storage, and then we just add the target over here on the Discovery tab, multipathing will already be enabled and everything will work correctly, as we already have the multipathing software installed. If you don't have some sort of multipathing software installed, don't check that box until you do. Then you just go right back into the login box, and then you can just check that box and click OK. It'll just reconnect in multipathing mode. So if we go over to computer management, we'll now see a whole bunch of storage on this machine. Now you'll need to do that on all your nodes of your cluster before anything's actually going to work. So we'll go ahead and flip over to our second node real quick in a second here. And you'll see all our nodes have shown up. And I've already assigned them their IP addresses for the most part. So you've got one new volume here, so we just need to bring that online just like it was a normal disk, initialize it. These are all small, so MBR is just fine. And create a new volume. And this is going to be our log drive, I believe. Oops. Yes, it's going to be our log drive, so we're going to mount that as the L drive. Call it data log, data underscore L rather. And we're just going to do a quick format for a demo. We don't want to burn 10 minutes waiting for a hard drive to format. So there we go. So we got all our volumes now. So we're going to go ahead and flip over to our second machine. And we're going to do the exact same setup over there. Oops, close those. iSCSI initiator. Yes, we want to start it. And yes, we want to unblock it. That'll come up the first time you ever fire it up. So 10.3.0.30. And we see the exact same target. So we're going to go ahead and do the exact same logon procedure for all of them. Obviously, the more targets you have, the more volumes you have as targets, the more tedious this gets. You get 20 or so targets per server that you're mounting to your cluster on. Say a 4-node cluster, this can get real old real quick, obviously. So we don't need to do anything in computer management on this machine. So we can go ahead and get rid of that machine. Come back to our first node. Go ahead and close computer management. And we're going to go ahead and open up the failover cluster administrator now. Right out of the administrative tools. And that just pops right open. So the first thing we're going to do is we're going to validate a configuration. Now this isn't necessarily required to build a cluster, but it is necessary that you pass a validation to install SQL under a cluster. Otherwise the SQL installer won't install at all. And it'll just throw a failure message. So we're going to go ahead and type in both the names of our two nodes. And it's just going to verify that it can find both the machines. So one of the things I do recommend, which I forgot to do, is that you go and disable the Windows firewall when you're clustering these machines. The reason for this is that Windows clustering has to do a lot of communication between the servers, and it's just a lot easier to get done if the Windows firewall is disabled. Obviously not best practices. I'm showing you both ways you can turn the firewall off here. But best practices and making your life easier don't always get along. So as you can see, in this time, it just added it right on in there. So we're going to go ahead and run all tests. So this is going to take a few minutes. So through the magic of the internet, you're not actually going to sit here and watch the entire thing run. Okay, so the failover cluster validation has completed. So the end goal you're looking for here is a nice big green check mark. If you don't have that, scroll down and see where your problem lies and click view report here. Get a nice HTML report of where your problem is. So now that we know that we can create a cluster, we'll go ahead and do so. And click next through there. We'll just enter our server names one more time. And we click next. The name of our cluster is going to be SQL 01. And we go here and type an IP address in here. And you can only type in that last part of the subnet, whatever part's changeable. So in this case, our IP is going to be 10.3.0.33. And we're going to click next. Now I know the IPs that I'm actually using don't match what was in the slide deck earlier. That's because those are examples, and this is the way my network is actually laid out. So we go ahead and click next. Now when you're picking the IPs, obviously they'll give you the standard warning, don't just pick random IPs on your network. You're going to actually want to talk to your sysadmin or your network engineer and actually get IP addresses issued so that you don't cause any sort of outage to any other systems by using IP addresses that have already been allocated to something else. So this wizard takes a few minutes to go through because it's got to create computer objects in the domain, add DNS records to various things and whatnot. So through the magic of the internet, we'll go ahead and come back when that's finished. Okay, so that just takes just a minute to finish. So we're going to click Finish on there. And you can see up here, we now have a functioning cluster. So we've got 2 nodes in our cluster. We don't have any services configured yet, but we're getting there. So we can now go to Configure a Service or Application, and we can go ahead and add in MSDTC. It'll check to make sure it's available. It's going to pick a name. In this case, we're just going to stick with the default, SQL 01 DTC. And our IP address is going to be 10.3.0.34 in this case, because again, it's a unique name, so it's got to have a unique IP address added to it. And apparently that already exists in Active Directory, because apparently I forgot to delete it after the last time I ran this. So I'm just going to go hop over to Active Directory and delete that real fast. And it's just going to go ahead and validate the settings against the domain, make sure that's available. So then we can pick the storage that we want to use. So you can see all the storage devices or all the drives listed here that are currently available. You know, if the Quorum drive is not available, that's already in use. So in this case, the F drive is going to be the drive we're using for MSDTC. So we'll just check that and click Next. Little summary page here. And just click Finish, and that's going to go ahead and add it in. And if you look up here in the upper left, you'll actually see the service has already been listed there. And we just let it finish up here. And once it's done, you'll get a nice little report here that says that it completed successfully. So at this point, MSDTC is installed, and it should be started here. Oh, not quite. Services are still coming online. Nice. So you can see the name has come online, so it's been able to successfully register in DNS. It's taken the IP address, and we've successfully started DTC. We can see that it's currently owned by SQL 01B, so we should right-click on it. We're going to move this to another node, and any other nodes in your cluster will be listed here. So we'll just go ahead and move it on over to the A node, and we can see everything come offline. And then real quick, within a few seconds, everything will just come right back online. And now everything's going to be owned by that A node in our cluster, which is the machine we're now on. As you can see, everything's back online. And at this point, we are ready to install SQL Server 2008. So we're going to go ahead and install Often Network Share. So we're using DFS to host everything here. So just hit the path real fast here. Go ahead and use the developer edition. That'll let us do a clustered install. So this install is going to go a lot faster than one normally would when you're doing it, because I'll be stopping the recording and starting it at various points throughout where a lot of time is normally going to be taken up. So to do an install, we can click on installation just like normal, where you normally install SQL on a standalone machine. You click that first link, so now we're just going to go ahead and click that second one right there. And that's going to go ahead and launch the clustered installer. So when we get to our second node, we would then click the Add node to a SQL Server failover cluster. And it'll give us a much, much shorter wizard that we're going to run through at that point. It'll just grab most of the settings from the initial node, and then it'll do whatever it has to do, all the installs and do anything it has to. And it asks a couple of questions about where stuff needs to go. And that's pretty much all that one's going to ask you. So most of these screens are going to look very, very similar. So those ones I'm just going to kind of breeze right through and not talk a whole lot about. The cluster screens, or cluster-specific screens, are the screens I'm really going to pay attention to. So I'm just going to go for the product key that's already in there. Standard license term information. Installing support files. This is all the same stuff you normally do. Alright, so we're going to go ahead and we're going to get basically the same setup support rules that you'd normally see. You'll see a couple extra things that are going to throw you off. The network binding order here. Basically, it's just telling you that it wants the TCP bound to the public NIC before the private NIC. So we're going to go ahead and install the database engine. And that's all we're going to go ahead and bother to install. We don't need client tools or anything on this machine. And we're going to go ahead and put the shared tools in the C drive. Now, that's not where the database paths are going to go. That's all configured later on. So SQL Server network name, so this is going to be the cluster name, or the name of the resource group, and it's going to be the host name that's used to connect to the SQL Server. So in this case, we're going to go SQL 01 v01, the default instance. All that can stay the same. You can change the instance root if you need to. Again, that's not going to affect where the data files are going to get written to, because those all have to be written on the shared storage, not on the local storage. You want all your binaries and whatnot on local storage, not on shared storage, because your binaries don't need to fail back and forth. Every node is going to have their own copy of the binaries installed on them. All right, so we get our standard summary page here. Click Next. So this is where we're going to get to the more cluster-specific stuff. So we've got a default group name here of SQL Server and MS SQL Server, which is perfectly fine if you want to leave it. Personally, I like to name things the same, makes them easier to find. So I personally use the name of the machine name that I'm going to connect to as the name of my resource group. When you get lots of resource groups in here, it makes it a lot easier to figure out what's where. Totally optional, or if you've already created your resource group, you can select it here. The ones with the big red boxes are not available for use. We click Next, go to our next screen. It's going to make sure that name is available on the domain real fast. We can see what disks do we want. Unfortunately, you can't see much information about the disks, but you can see that those are the three available, and we know those are the three we want. So we click them, we click Next. We're going to find what kind of network do we want. If you're using Windows 2008 as your host, you're going to be able to use DHCP if you so desire, or you can go ahead and just enter in a static IP address on that public subnet. In this case, we'll just go ahead and use DHCP. We click Next. So this is where you get to your security policies. If you're running on Windows 2008 Server or above, it's recommended to use your service SIDS. If you're running on Windows 2003, which is possible, you're going to have to use a domain group. The service SIDS option won't be there, and these are going to be the same domain groups that you would use in a SQL Server 2005 installation. So we're going to go ahead and use SIDS. We get to your standard account information. So the used account still needs to be a domain account. And you can set the SQL agent to fire up automatically or manually. In our case, we're obviously going to want that automatic. Sorry, we don't want that automatic. This is a clustered install, not a standard install. So those have to be set for manual. Sorry. The reason for that is SQL doesn't start by itself. The cluster service is actually what's going to start the SQL service when the machines come up and when it fails over. So you have to leave those at manual. Apparently I typed in my password incorrectly. So let's go ahead and validate our username and password real quick here. And we move on to the next screen. So these again are going to look very, very similar to what you're used to seeing. And just add my account. I've got lots of accounts here. So let's go with mixed mode is fine. Data directories. Going to go ahead and tell it that we want to put where we want to put the various databases. I like to put everything here. So we're going to put our user databases on E drive, our logs on L, our temp DB on T, our temp log on T, and our backups. We'll go ahead and just leave those on E. Now, any drives that you select in here have to be clustered resources. If they're not, SQL can't use them to host storage. That includes tempdb, even though it's recreated every time. So validate our cluster, check everything, we click install, and you sit back and wait for about half an hour. So this is just going to look exactly like a normal install is going to look. It's just going to go ahead and copy everything over, put all the registry keys in place. And the only additional thing it's going to do is it's going to create that resource group in the cluster, and it's going to add in all the cluster resources, including the IP address, the network name, all the drives, and the various SQL resources, which we'll take a look at as soon as this install is complete. Okay, so as you can see, our SQL installation is complete on this node. So we can go ahead and click OK and close out all the SQL installer stuff. Go back to the failover cluster manager. So you see we have a new option here, services and applications. So you can see all our various disks, our SQL Server, and our agent. So everything's happily running. We can't actually fail it over yet because we need to do the install on our second node. So we can switch back to our second node and close out of those windows we had open before. So we're going to go ahead and go to the same path and go ahead and grab just the same SQL installer. There we go. SQL 2008 developer. Let's run the setup real fast here. Now, like I said earlier, so we're basically just going to run the same installer, but we're just going to select the add a node option. It's going to do a lot of the same checks and whatnot and make sure that everything's still there. But the bulk of the questions it doesn't need to ask us anymore, because it can either get that from the other instance or it's stuff that's stored within the instance, and so it doesn't have to ask us about it. Stuff like where the paths should all be stored. That's all going to be basically queried from the other machine and grabbed from the instance when SQL starts. So installer's fired up here, so we're just going to run through the same checks and install all the same prerequisite tools. I'm just going to burn through these real fast here. We don't really need to talk about this stuff. Alright, so the actual installer itself has gone ahead and fired up. You can see there's a lot less options here, a lot less screens that we're going to have to go through. Instead of the normal like 12 or 14 or so, it gets cut down to about 6. So same basic checks we would normally do. See, what instance are we going to be dealing with? You just got a little drop down here, Microsoft SQL Server. We're dealing with the default instance. Just hit next. Now it's going to ask us for our service account information, so it's going to be the same information we entered on the other screen, on the other server. There it goes. So it's already got the username filled in since it knows that, but it's got to ask us for the password because it doesn't know what the password is. That's obviously just for security purposes. We'll go ahead and enter that. What information you want to send to Microsoft, whatever you feel is necessary or whatever you're allowed to do based on your corporate policies. So we just click install. Now see, I burned through a lot of these screens because a lot of this stuff's very redundant. I do feel it's important that to show everything that you're going to be seeing when you actually go to do this in your own environment. That's why I show it. I just kind of click through it really, really fast. You can always download this presentation after the fact, and you can go through it and pause it where you need to. Actually, you can't click as fast as I can. Obviously, this isn't the first time I've done this. I've run through this installer a couple of dozen times probably by now. So this point is actually doing the install. It's done asking us questions. So this takes about 15-20 minutes, just like it normally would. Once it's done, we'll get the complete wizard up, and then we can go back to the original node, or we could fire up the failover cluster administrator on this node, and we can see that we can fail the instance back and forth, and we can see the services starting and stopping on the various nodes. Okay, at this point you'll see that the add node wizard is complete. Hopefully your screen will look like this when you're done. It took about 10-15 minutes to actually complete the entire install process. So we just click close. And at this point, we're going to go ahead and switch back to our first node, and everything still looks the same here, but we can go here and move the node over to the other, or move the services over to the other node, and we'll see all the services drop offline, and then we'll see them all slowly come right back online. First the disks, then the name and IP address. The IP address is online. The name is just coming online, so that means it's just going to DNS and making sure that it can register that name correctly. And then the services are going to go ahead and come right online within just a few seconds. As you can see, failover, fairly quick. And these are on some very, very low power hosts that are running under, or virtual machines, which are running under some fairly low power hosts on top of that. And everything's still able to come online really quickly right after that. Then to connect to this, we simply open up SQL Server Management Studio or whatever application we want to use and simply point it to this network name right here. And we're online and doing whatever we need to do in SQL. So some benefits to working in a open SAN software environment like the StarWind iSCSI target. It's compatible with pretty much everything. It's one of the great things about it is it's universal. It's using standard non-proprietary technologies. This is standard iSCSI Ethernet. You'll notice when I did my demo, the iSCSI target was StarWind Software's. The iSCSI initiator on the SQL 01A and B servers is actually the Windows iSCSI initiator. So not provided by StarWind, it comes straight out of the box from Windows. So this is all standard, industry standard technologies. It's working over a standard Ethernet network. Or standard private IPs on the internal network, and everything's talking to each other. We could be talking over a LAN, over a WAN, over a VPN connection, whatever we needed to fit with our enterprise requirements. You can use any of your standard equipment. You don't have to go out and buy a really expensive storage array to get good storage performance. You just can go buy a standard JBOD, put a bunch of hard drives in it, attach it to a box, put StarWind software on it, boom, you've got an iSCSI SAN that you can now attach to, you can cluster, you can do all sorts of great DR solutions with. Works on any hardware, 64-bit or 32-bit. And so you're basically just then converting a standard Windows server into network storage that you can use for any application. So it's very reliable software. I've been using it for 6 months or so at the minimum here. It's very scalable. They've got all sorts of DR options you can use for it, so you can replicate between target servers so that you've got a zero downtime data scenario between sites. All sorts of great options for you there. So you've got all sorts of things you can do with it. As you can see, we've just used it for clustering, which gives you high availability. You can use it for VMware or Hyper-V. These particular VMs, as I think I mentioned earlier, are running under VMware. So my target is running under VMware, as are my hosts, as are my servers. So everything's virtualized. They're running on different physical boxes in my VMware environment. So everything is talking over a physical Ethernet layer. But the boxes themselves, the machines themselves are virtualized. Storage consolidation, obviously any sort of consolidation is very, very big in this type of economy. So if you can consolidate storage onto existing IT resources, that's even better than going out and buying a big piece of new piece of metal and using that for your consolidation. Obviously, you get all sorts of server consolidation options now, because you've now reduced your storage down to a single box or a couple of boxes, so you can replicate back and forth between them. So you can now reuse some of those additional boxes that were just sitting there as storage targets, or providing storage for other boxes. Maybe you can reuse those, make them virtual, VMware or Hyper-V boxes, do some sort of virtualization, do even more consolidation on top of the consolidation you've already done. You get all sorts of DR options, like I mentioned earlier. You can replicate from one site to another using the StarWind software. So you can present iSCSI SANs at both centers, have them replicating back and forth, do all sorts of geo-distributed clustering options, or just database mirroring, something like that, and have SAN storage available at both sides. And you have shared storage, which is obviously a requirement of the SQL Server clustering or the Windows clustering we did earlier. So all sorts of choices there as well as to how you want to present stuff, and you get a lot of shared storage options that you wouldn't get just by buying a JBOD and attaching it to the backside of your server. So some of the enterprise and DR features that you're going to get by using StarWind Software's iSCSI targets are, you got point-in-time snapshots, which are a big deal in the storage world. Basically, you can take your storage and instead of, we have snapshots in SQL, so instead of telling SQL, hey, take a snapshot of this database, you can tell the storage, hey, take a snapshot of the storage at this point in time. So you have a backup of everything that the storage had on it at that exact point in time, block level backup, or block level snapshot rather. You get synchronous data mirroring between your two StarWind servers. I mentioned that earlier. You're doing data replication within your server room, and then of course what sort of data replication or what sort of data mirroring would it be if you weren't able to do replication across your WAN to your remote DR site, so you can get a 24/7 business continuity solution in place without having to buy a lot of metal to put all that on. StarWind supports thin provisioning, which is very big in the storage world. So basically you tell your host that you've got 50 gigs of storage, but if the host is only using 5 gigs of storage, it only actually has about 5.5 gigs in use to get a little bit of overflow space there to work with. And then as more space is needed, the storage array simply allocates more space to it. All the big guys are doing this, and it's really great that StarWind supports this as well. Obviously, this requires a little more management than just allocating storage in mass. But if you've got that overcommit that you can use, and servers want, business wants that space, but they don't actually need that space, this is a great way to give it to them without actually them having to have it sitting there idle doing nothing. Let you have a much, much better utilization on your array and on your storage. And last bullet on here is there's lots of other features. All sorts of I/O caching, NTFS compression, and encryption is integrated. Lots of shared volumes for clustering, RAM disk, 64-bit and 32-bit architectures, MPIO, which we mentioned earlier. You can do all sorts of rating within it. They support virtual tape libraries. These are all buzzwords that your storage guys are going to understand. We're not going to have time, unfortunately, to get into right now. So if you'd like to download a free copy of the StarWind software, they've got a free trial available for you, which you can download right here off starwindsoftware.com. And their contact info is right there. If you have any sales questions or any support questions for them, feel free to hit them up. They're a great group of folks over there. Then if you'd like to go ahead and open it up for Q&A in the little Q&A area on the website here. And thanks a lot.